Okay, hello grade 10 student and welcome to a new video. In this video we are going to solve the application from 3.1 acceleration part 2. So application 1, an object on a straight horizontal track with a change in velocity of delta v is equal to 12 meters per second. So the change in velocity which is given by delta v is equal to 12 meters per second. During 10 seconds, so the time interval for this change is, for the duration is given by 10 seconds. Now, which of the following is the average acceleration? So we are looking for A among these choices because this is an MCQ question. Now let me write here that we are looking for A. In order to find A, let's construct the relationship among A, delta V, and delta T. Now since we are looking for A, we should hide A. As a result, the expression will be delta V over delta T, which is equal to, now delta V is given by 12, delta T is given by 10. Now if we divided 12 over 10, we will obtain the value of the acceleration, and in this case the acceleration is 1.2. Now regarding the unit, since the numerator is expressed in meter per second, this is the SI unit for the velocity or the change in velocity. Here in the denominator it's expressed in second according to the given. We know that meter per second is the SI unit for the change in velocity, the second is the SI unit for the time, so the output, the answer should be also expressed in SI unit, and we know that the SI unit for the acceleration is meter per second squared, so the correct answer is C. Now for application 2, a shuttle bus slows down with an average acceleration. So slows down, which means it's decelerated motion of a magnitude. So here I want to pay your attention that in the question they provide us with the magnitude of the acceleration. Now the magnitude of the acceleration is 1.8 meter per second squared. How long does it take the bus to slow from V0, 9 meter per second, to complete stop V final 0? So the initial velocity before the bus decelerates its motion is 9 meter per second. Now this represents the velocity. The direction of this velocity is positive because we don't have any sign here. Now the final velocity, because since the object will stop, the final velocity will be 0. Now let me write down the ingredients. The magnitude of the acceleration is given by 1.8 meter per second squared, and the initial velocity V0, or you can write it as VI, 9 meter per second, and the final velocity, it's equal to 0. Now what does it mean by how long? How long means we need to calculate the time to force this bus to decrease its speed from 9 to 0. In order to find the time, we should apply the formula that represent the relationship between A, delta V, and delta T. Now since we are looking for delta T, we should hide it, so delta T is equal delta V over A. But before I start to substituting the values, now let's evaluate the direction of A, because here we have the magnitude, but in the formula we should include the direction. And we cannot assume that the direction is positive unless if we evaluate correctly the relationship between acceleration and the initial velocity. So let me explain now that since the velocity is positive, so it's directed to the right. Now in order to destroy or dissipate the velocity, you should apply the acceleration, but in which direction? Since we are slowing down the bus, the acceleration should be applied in a way that it will destroy the velocity at the end. This is why I will apply the acceleration in opposite direction of the velocity. Now we know that right is positive, left is negative, so the direction of acceleration should be negative, which means the acceleration, not the magnitude, the acceleration is given by minus 1.8. So I should add minus here. As a result, when I'm going to substitute, I should include the sign. Now the delta V is not given here. However, we have information about the initial and final velocities. So let me write here, or let me expand the delta V into two components, the V final minus an initial. Now over the acceleration, finally, let's substitute the values. Now the final velocity is 0 minus the initial velocity is 9 over the acceleration, which is 1.8 or 1.8, yes, the minus sign. Now delta T is so 0 minus 9 over minus 1.8, and the answer is 5. So the correct answer is 5. And the unit used here is second, because the numerator is expressed in the SI unit, the denominator also is expressed in SI unit, so the output or the answer should also express in SI unit, and the SI unit for the time is second. This is why I will choose choice D. Application 3, with an average acceleration of minus 1.2 meter per second squared. So here they told us that this is the acceleration. Now we know the acceleration include information about magnitude and direction. Now the sign will represent the direction, and the numerical value with the unit will represent the magnitude. Now, how long will it take a cyclist? So one more time, how long means the delta T, we are looking for delta T, to bring a bicycle with an initial speed V0, 6.5 meter per second, to a complete stop V final equal 0. So let me write first the ingredients before I start solving the problem. The acceleration is given by minus 1.2. No need to adjust the direction because it's all already presented here. Now the final velocity, or let's start with the initial velocity. The initial velocity V0 is given by 6.5 meter per second, and since the bus or the object will stop, cyclist will stop, this is why I should replace it by velocity is equal 0 as given here. Now here we are looking for delta T. Let me construct for you the triangle A, delta V, delta T. Let me hide delta T. As a result, delta T is equal delta V over A. One more time here, they didn't mention directly the delta V. However, they provide us with information about V initial and V final, and we know that delta V is given by V final minus V initial over A, which is equal. Now the V final is given by 0, the V initial is given by 6.5, and finally the acceleration is given by minus 1.2. And the answer is $5.41. Also here, this is SI unit, this is SI unit, so the answer should be expressed in SI unit, and we know the SI unit for the time is second. This is why D is the correct answer. Suppose a treadmill has an average acceleration of, so this is the value represent the average acceleration, meter per second squared. So let me write here A is equal 4.7 times 10 to the power minus 3 meter per second squared. Now in part A, they provide me, or they want us to find the change in speed after 5 minutes. Let me recall that since the object or the athlete here is moving in one direction, we can consider that the change in speed is similar to the change in velocity. So as long as the object is not changing its direction, the change in speed or even the speed, the average speed will be equal to the average velocity or the change in velocity. So I can say safely that you can apply directly this relationship in order to find the change in speed. So A, delta V, and delta T. Since here in this particular case, the delta V is equal to delta S, where delta S is the change in speed, and delta V represent the change in velocity. So the delta T here is given by 5 minutes. We know that 5 minutes is not the SI unit for the time. We should convert it to second, and we know that from minutes to second we multiply by 60. So we just multiply by 60 and it will give us the equivalent second of the 5 minutes. Now let's hide the delta V in order to find it. A times delta T, which is equal to, the acceleration is 4.7 times 10 to the power minus 3. The delta T is given by 300 seconds. As a result, let's plug the values on the calculator. So first we have 4.7 times 10 to the power of minus 3 multiplied by 300 seconds, and the answer is 1.41. Now what will be the corresponding units? We know that the SI unit for the change in velocity or speed, as well as the speed itself or the velocity itself, is given by meter per second. Now for part B, if the treadmill's initial speed, so we have information about the initial speed. The initial speed is given by 1.7 meter per second. We found in part A that the delta V is equal 1.41 meter per second. We have the initial velocity. We still need the final velocity, and there is a relationship that links delta V with V and V final. We can equate them to produce equation with one unknown. By solving this equation, we can figure out the V final. So let me do it together. So delta V here is equal V final minus V initial. Delta V, it's already solved, so 1.41. Now the final velocity is unknown, so keep it unknown. The initial velocity is given by 1.7 meter per second, so let me write here 1.7. Now this equation is called linear equation with one unknown. In order to solve it, I should move the minus 1.7 to the other hand side, but don't forget to change the sign from minus to positive. So 1.41 plus 1.7 is equal V final. By adding these numbers together, I will get the value of the final velocity. So let me find out. So the final velocity is 3.11. What will be the unit? Meter per second. Now a car traveling at 7 meters per second. This is the velocity. We have sign and we have numerical value. Now remember that the unit could be used in order to understand the nature of this quantity. Since the unit here is meter per second, we know that meter per second can be used for both speed or velocity. But since here also we have mentioned the direction plus, so this is definitely the velocity and not the speed. Now accelerate at a rate of plus 8 meter per second squared for an interval 2. Now we have the velocity, the initial velocity, the starting velocity, which is equal 7 meter per second. We have the acceleration, which is equal 0.8 meter per second squared, and the delta t, which is equal 2 seconds. Now we are looking for V final. Now let me remind you that in order to increase the velocity, we apply the acceleration in the same direction of the velocity. And this is actually what the question about. Since they have the same sign, they have the same direction. Now, what does it mean to have 0.8 meter per second squared? It means each second, the velocity will increase by 0.8, which means at the first second, 1 second, after 1 second, the speed will increase by 0.8. So I'm gonna add 0.8 to the 7, and after 1 second, the final speed is 7.8 meter per second. Now, after 2 seconds, another 0.8 will be added to the 7.8, and the resultant speed is 8.6 meter per second. Now, since the question is about the final velocity after 2 seconds, you can take this value as an answer for the final velocity. This is the first method. Just use the logic. By using the logic, we can obtain the correct answer. Now, can we use different approach in order to solve the same problem? Definitely yes. We can apply the formula of acceleration. So acceleration delta V over delta T. Since we are looking for the final speed, we know that the final speed or the final velocity is implicit in the delta V. It's inside the delta V. So we can say that the delta V is equal to acceleration times delta T. Now delta V can be expanded into V final minus V initial, which is equal A times delta T. Now we are looking for V final, which means I need to apply the isolation method in order to isolate the V final. And that can be done by moving the V initial to the other hand side. Don't forget to change the sign from minus to plus. So V final is equal A times delta T plus V initial. Let me substitute now the values. The acceleration is given by 0.8. The time is given by 2, and the initial velocity for sure it's 7. Now plug everything in the calculator and you will be able to obtain the same result that you found it in the first method. So the answer is 8.6 meter per second. Now this is application 6, an object on straight horizontal track with an initial positive velocity undergoes a constant acceleration. So here the velocity is positive, the acceleration is negative, so it's directed to the other side or in the other direction, and this is obvious since the velocity is positive, which means to the right, and the acceleration is negative, which means to the left. We can conclude that the velocity will start to dissipate, to be destroyed under the action of acceleration for full 4 seconds. Now, they want us to choose among these choices A, B, C, D in order to find the change in velocity. And what do I mean by change in velocity? They want us to find the delta V. Now, in order to find the delta V, we can use the relationship among A, delta V, and delta T. Let me hide delta V. Delta V is equal 8 times delta T. Now, let's substitute the ingredients. A is given by -5, delta T is given by 4. Finally, the answer is -20. Now, since this is delta V, the answer should be expressed in meter per second. This is why I will choose A. Now, the final answer for this lesson is application 7. Two cars pass by each other on a straight road, as shown here. We have two cars. Car 1 has speed V0. So this is actually car 1. And also here we have the direction of the velocity, which means we have the direction of motion. So car 1 is moving to the right. And we have another car 2, has the same speed but now to the left. So velocity here is to the left. The direction of motion is to the left, which means the car is moving to the left. Immediately after passing each other at this moment, both cars experience a constant acceleration directed to the left. So let me draw this acceleration vector to the left. Which of the following correctly describe the change in speed for each car? So they want us to choose among these choices the correct row that reflect what is going on here after we have activated the acceleration. Now let me remind you that if you apply the acceleration within the direction of velocity, the velocity will start to accumulate, or the velocity will start to increase. Now if you apply the acceleration against the velocity, what will happen to the velocity? It will start to dissipate. The velocity will decrease. Now as a result, since A and V0 have the same direction here in the car 2, the speed will increase. And since A and V0 have opposite direction car 1, for car 1 the velocity will decrease. This is why the correct answer is decrease for car 1 and increase for car 2. So C is correct.